Question. Consider the equation Px, that is ax square plus bx plus c is equal to 0, whose coefficients a, b and c are all non-zero, and each of them satisfies an equation that results from removing the term containing that coefficient from the equation Px. For example, the coefficient b is the solution of the equation ax square plus c. In the previous equation, the term containing b has been taken out, so what is remaining is ax square plus c is equal to 0. Then the question is, what is the sum of all the solutions of Px? Possible answers are always 1, or always minus 1, or always 2, or 1 or minus 1, or the final one, E or 2. To find out the value of the first coefficient, A, we have to remove the term containing A in Px. Then the equation becomes Bx plus c is equal to 0. This equation will give us A. That means the solution to this equation, when you replace x with A, will give us the value of A. So replacing x by A, we get AB plus C is equal to 0. We call it equation 1. Similarly, removing the second term from Px, we get ax square plus c is equal to 0. This gives the value of the second coefficient b. Therefore, we get ab square plus c is equal to 0. We call it equation 2. Finally, we remove the third term from Px to get ax square plus bx is equal to 0. Solution to this equation will give the third coefficient c. Therefore, ac square plus bc is equal to 0. Let us call it equation 3. Equations 1, 2 and 3 are three equations for three unknown quantities a, b and c. It should be possible to solve them to get the values of a, b and c. Let us write down the three equations again. The first equation is ab plus c is equal to 0. The second equation is ab square plus c is equal to 0. And the third equation is ac square plus bc is equal to 0. Subtracting equation 1 from equation 2, we get ab square minus ab is equal to 0. Or if you take ab common, then ab multiplied by b minus 1 is equal to 0. Since a and b are not 0, we can divide both sides by ab. And we get b minus 1 is equal to 0. Therefore, b is equal to 1. So we have got the value of one of the coefficients. Now that we have found the value of b, then that is equal to 1, we put this value of b in equations 1 and 3 and we get a plus c is equal to 0. Let us call it equation 4. And we get ac square plus c is equal to 0. Let us call it equation 5. Subtracting equation 4 from 5, we get AC square minus A is equal to 0. Taking A common, we get A multiplied by C square minus 1 is equal to 0, and since A is not 0, we can divide both sides by A to get C square minus 1 is equal to 0. Or C square is equal to plus 1, and therefore C has two values, plus 1 or minus 1. From equation 4, we note that A plus C is equal to 0, therefore A is equal to minus C. Since C is equal to plus minus 1, we get A is equal to minus plus 1. Now the equation Px, that is ax square plus bx plus c is equal to 0, is a quadratic equation in x, and it has two solutions given by x is equal to minus b plus or minus root over b square minus 4ac divided by 2a. That means one of the solution is x1 is equal to minus b plus square root of b square minus 4ac by 2a, and the other solution is x2, that is equal to minus b minus square root of b square minus 4ac by 2a. Therefore, the sum of the two roots, that is x1 plus x2, will be minus 2b divided by 2a. That is because the term under the square root sign will cancel out when you add the two solutions. So x1 plus x2 is equal to minus b by a, which is, we know that b is equal to plus 1, therefore minus b is equal to minus 1, and a is equal to plus minus 1. Therefore, the sum of the two roots is plus minus 1. Out of our choices, therefore, the choice D, which is plus or minus 1, is correct.